Azure operates at hyperscale, and Azure infrastructure design is really optimized for that level of hyperscale. That's really the starting point for us. And then Azure Stack is same services, same APIs, same templates, same semantics, but it's really operating at a much, much smaller footprint for all our customers to go deploy and bring up their own Azure services. So I have a animation here. This shows all the different pieces that go into Azure infrastructure. There's Fabric Controller, the front end, the resource providers, the reporting metadata service, a bunch of things, right? When I show these blocks, each one of these is, when I say cluster, it could be like literally hundreds of physical machines operating together, right? All these things then come together and become one region and provide cloud services. Now, what we are really doing here is we are taking all those services and really putting them all, scaling them down into a box, right? And of course, not one box, multiple boxes here, right? So that's really the takeaway. So it's sort of typically folks start off small and try to scale it up, and they run into challenges and they come up with cool solutions. It's the opposite problem for us. Azure is operating at hyperscale, and their backend is designed for hyperscale. We're bringing all the services and into the SDDC capabilities of Windows Server 2016, and that's really what our focus is going to be on. First of all, IaaS, why bother? What do I mean by IaaS? Again, pardon me if you know these things, it's just I wanted to set the context here, right? Virtual machines, disks, NICs, networks, right? And when we start talking about Azure consistency with our customers, Azure Stack customers, the VMs are always like the touchstone. That's always what they think about when we start discussing consistency, right? So IaaS is really the very first step when folks start thinking about cloud consistency. And almost every server application, SQL, Exchange, et cetera, they all require IaaS infrastructure, of course. And all the PaaS services, they really build off of IaaS primitives. So think of IaaS as providing a bunch of foundational services, as the name indicates, to all other things to build on top of, right? Now, before we go into the individual sections, let me give a couple of top-level details on what Azure Resource Manager and Resource Providers are. Again, you may have heard some of these things in other sessions. Azure Resource Manager is the primary glue that uses the Azure Consistent Resource Management for us in Azure Stack, right? That's really the same code that runs in Azure. We bring it on-prem, we make it part of Azure Stack. So that's the common denominator for our management plane across Azure and Azure Stack. And clients, there are multiple clients. You could be programmatic clients using our REST API libraries. You could have PowerShell command layers, Portal. They all consume off of those services provided by ARM, right? And under that, resource providers are really, we are very focused on infrastructure-specific plugin into ARM. You can almost think of it as a plugin under ARM, right? We have storage, compute, networking, and a bunch of others. For this session, we're going to focus only on those three that I called out there. So how do users communicate with ARM, right? Well, we talked about PowerShell and all those. They're really the manifestations. But under the covers, what's really going on is there is a declarative statement of the desired state, right? That's what we call as a template. And the template says, hey, here are the resources that I would like to be realized, and here are the parameters, here are the variables, right? And ARM takes those takes that declarative statement, and it performs the necessary orchestration. Hey, should I call CRP first and get some things done on the compute side and then go to NRP, or the other way around, right? Those sorts of orchestration, the process orchestration happening within, that's orchestrated by ARM. It also turns those declarative statements to a bunch of imperative calls down to individual resource providers. So resource providers get told, hey, go create the resource, go update this resource, et cetera. So the management plane is all consisted of a bunch of what we call as resources, right? There's ARM resources, or how the entire management plane manifests as our resources, and I'll have more details coming up on that. So TP2, Azure Stack TP2 enables a number of workloads. These are we have a bunch of templates on GitHub. You can see those, you can play with those. Obviously, this is not for production, as you guys can imagine, but that's why I said enables rather than really supports in production or anything like that. Obviously, more will be coming by GA, and eventually what we really would like to do is have each Azure template also be called out as, here are the parameterized enough that the same template could work for Azure and Azure Stack. It does work today, but because some of them are not parameterized, we have a different Azure Stack repository at this moment. And the cool thing is, of course, you can contribute to that repository as well. I just want to give a shout out to SDDC. There are a ton of new capabilities under the umbrella of software-defined data center. Did anyone attend Matthew, Sid, and yeah, they have a SDDC session a couple of days ago. And they give a sort of a whirlwind tour of all the cool technologies under the SDDC umbrella that came in Windows Server 2016, like VM storage resiliency, VM compute resiliency, and storage replica, and the network controller, and distributed firewall. There are a ton of cool capabilities that are all orchestrated through software-defined capabilities, right? And the connection here is, of course, Azure Stack is also software-defined data center capabilities. What we really is, we're building on top of the platform capabilities in Windows Server 2016 and extending them in a very interesting way, in an Azure consistent way, in a way that you could really monetize them with self-service provisioning and agility. All right, so let me get to the IaaS introduction demo. What I'm going to show is really a very quick demo that uses all the capabilities of the IaaS features that I just talked about. What we're really doing is we are provisioning a SQL server, and this is being run off of a gallery item. That's really what's going on. So at the end of the provisioning process, you would have a SQL virtual machine. You as a tenant would have SQL tenant virtual machine with the software installed, with all the hardware, with all the networking and storage appropriately configured. As you can see, you start from a template, and this is where you're seeing the VM sizes. These are consistent as in Azure. The same size name means A10 means the same thing here as in Azure, right? And you can see the storage also being used for this template, and then the IP addresses, the virtual network capabilities of the network resource provider are also in action here, right? So, and of course, the attributes specific to the SQL server that software being deployed on that virtual machine can also be configured, all using the template, right? Once you're done with all the settings, you review the settings and hit OK, and ARM does the magic for you. The orchestration that I was mentioning earlier, it goes ahead and starts what we call as a deployment under the covers. And by deployment, what we really mean is they're doing the orchestration, is translating those directives from declarative to imperative that I just discussed earlier. And once the VM is provisioned, this is basically the SQL server is up and running on the tenant IaaS virtual machine. Of course, this is a time-accelerated video, just so meaning that we took out somewhere it's just provisioning, deploying, and copying bits. There's not fun to watch, so I shortened that. But other than that, this is really something that you can do with TP2 software today. So let's move to storage-specific content. So that's the sort of very quick IaaS demo on how all these different capabilities are coming together and delivering value using templates and gallery items. Now, let's go a little bit deeper into storage. So one of the things that I just wanted to state up front is blobs. Hey, this is an IaaS session. Why are we talking about blobs in IaaS session, right? I'm assuming most of you guys already use Azure. Anyone, right? Yes? Okay. A good percentage, 50% of them almost. So blobs, all VM storage in Azure Stack resides in blob store. And this is consistent with how Azure does it, right? Azure, every VM disk, right? That's either OS disk, data disk, doesn't matter. All disks are blobs and page blobs. And page blobs are the kind of blobs that allow random access. They're optimized for random access, and they have large size limits. So in Azure Stack, the architecture, the semantics of it is identical. We also have page blobs, and we layer all of our VM disks as blobs. But we do something more cool. I'll get to that under the covers, what happens in a minute. Now, cloud storage for Azure Stacks, what do we mean by that? Blobs, tables, queues, and storage accounts. They're all directly tenant accessible resources. Again, when I'm using the resource word, I'm think about the ARM resources, right? So these are the same as in Azure. Tenants can use it in Azure Stack, same semantics. That's good. In addition, we also have administrator manageability. Obviously, when you're standing up an Azure Stack, you are really like Azure is managed by Microsoft, of course, and Azure, the administrator there is us. But in this case, you want deep administrator manageability for all the IaaS stacks that we're discussing here. And so we have a ton of cool administrator manageability, and administrator manageability is also exposed as a bunch of ARM resources again, except those are RBAC controlled. Only administrators can access those admin resources. You can, of course, deploy it on enterprise private or hosted clouds. And when I say IaaS, I know this is an IaaS session, so we're going to focus on page blobs only going forward. But we also have a bunch of cool PaaS capabilities, block blobs, append blobs, tables, and queues is a new feature that a big new feature that we have added in TP2, which we shipped earlier this week. And we already touched on the SDDC side of the story. Let's go into the solution view. This is giving a little bit of internal detail. Before, I'll discuss them just so it's interesting and it's something it would be cool for you to know how all these different technologies are coming together. But realize that Azure Stack TP2 deployment does all these things for you. You don't really need to go build all these things yourself by hand. So ignore that aspect of it, but just take a look at what's going on here. We have a set of infrastructure services and a set of virtualized services, right? When I say virtualized services, what do I mean? I mean that there are actually two service fabric clusters that are running on virtual machines, right? And that whole detail about virtual machines, all that is all hidden from you. You don't need to worry about it. All you need to know is, hey, there are two clusters. One cluster provides data services, and the other cluster acts as our management plane. That's where all our resource providers run, right? And there are a set of services that actually run across both these clusters, of course, and these are all tenant-facing services, blobs, tables, queues, and accounts. And we also have administrative services, as I mentioned. And there are a ton of application clients. The orange, does it look like orange? Sort of. Yeah, the orange clients up and to the left, right? Those clients are all really the same code as in Azure. Right, it's same. You can take the same APIs, same storage client libraries, same PowerShell commandlets, same tooling, storage, Microsoft Azure Storage Explorer. All those tools work without any changes. In fact, they have the same binaries, right? On the ones in the red onto your right, those clients are really clients written for Azure Stack because they have to do with admin functionality. They feed off of admin side. And there are some of those. And infrastructure services, we have blob service that runs directly on each individual cluster node, and we're using the storage spaces direct technology, which is a shared nothing dash storage cluster under the covers, right? So there's a blob service endpoint that each node exposes, which the virtualized services consume. You see there's a blob service up at the top in the virtualized services bucket. There's also a blob backend. So the front end talks to the backend, and there's the whole Azure consistent blob functionality is delivered from a client perspective. The management model, the accounts for tenants, provisions and manages lifecycle. Storage accounts give you the root namespace for all the objects that go into that account, as you know very well. An administrator has access to admin resources. I already mentioned this. And there are different kinds of administrator resources here that I just wanted to call out. For example, when we say storage farm, we mean all the storage infrastructure and services that together provide the storage services in that region. There's also services within the farm, of course, blob and table and queue are examples of storage services. Storage service role is front end, back end. Within a blob, as we had seen just now, there's a front end and the back end, right? So let's take a very quick look at how the storage management translates to tooling. Azure Resource Manager and SRP, we talked about that. Using a sports metaphor here, right? I mean, there's all footballs. The tenant resources are all the same. We have one kind of tenant resources, and there's existing tooling that consumes those tenant REST APIs. They're all to do with somehow the CRUD operations, create, read, update, delete operations on storage accounts. And we also have a bunch of admin resources. They're of different kinds, continuing the metaphor. And there's a different set of tooling written for those admin resources, and that knows how to speak with those new REST APIs, right? And there's some internal communication also happening between SRP and CRP, which I'll come to in just a second. The relating Azure storage concepts, again, pardon me, this is really more for your reference, so I'm going to just click through this. It's just showing you the containment relationship across the different objects and different concepts that we talk about in the demo. IaaS VM storage. Remember I mentioned to you that all VM storage resides in a blob store, both in Azure and Azure Stack. Every OS disk is a blob. And I'm adding another dimension here now, which is each page blob in Azure Stack Design maps to an REFS file, REFS volume on the storage space's direct volume, right? And then the other thing is every blob, of course, acts like a blob. It can be accessed through REST APIs and produces Azure consistent semantics and all that good behavior you can expect. But there's also something that's more happening under the covers. CRP and SRP collaborate under the covers to ensure that when the VM starts running at the VM runtime, the VM actually uses the most high performance Hyper-V or SMB path that gives us SMB multi-channel, SMB direct, RDMA functionality, all that, right? So there is no REST API to another protocol translation going on here. It naturally switches to high performance mode at the VM runtime. All unbeknownst to you, you as user, you don't care, you don't need to know. I'm just giving you some color on what's happening under the covers. This graphic, we will click through this quickly. This is really what's happening between SRP and CRP when you take a marketplace image or a custom image, doesn't matter. Scott is going to talk more about some of that coming up. But what happens under the covers, right? As a tenant, I provide all this. Azure Resource Manager reaches out to CRP under the covers. CRP puts the new blob B1. Here I as a tenant, I'm saying, hey, I have an image, catalog image K. I'm using blob B1 for my OS disk, right? The new blob B1 is instantiated in the blob store, and see how the blob is sitting on a file share at the end of the day. That's an important thing to remember. Because it's sitting in a file share, sitting in a REFS file system, it has a path. It can be accessed like a file, right? And then CRP asks SRP for the access path of that B1, and then once it gets that, then CRP pokes SRP again to say, hey, can you please copy this image to this file that you just told me about? So SRP uses the most efficient copy semantics under the covers, and it copies the image over, and then CRP configures Hyper-V, and Hyper-V accesses it over SMB, right? So the REST API path is still active at the time you're provisioning, but once it's provisioned, once the VM starts running, REST API goes into dormant mode. It's only accessed through SMB path, and the VM is created. So this is really for your reference. I'm not going to walk through each one of these. There are certain differences that we know about. We're just letting you know. Once you start playing with TP2, you should know that there are a few changes, differences that you might notice, right? There are some mirror differences, no files, etc. So let's not, and the configuration guidance, again, this is for your reference. As you can see, test only. Please don't stand it up in production. Not optimized for performance and scale. That said, please do let us know what kind of performance scale expectations, what kind of applications you want to build on top of these, and what are you thinking about in terms of where it's falling short, right? Please do let us know those things. So single node hyperconverged scale-out file server, dash storage for V1. And these are the API versions in case you're playing with some applications and bringing them from Azure and trying to run on Azure Stack. These are the API versions that you should know about. With that, let me just go do a storage demo. As part of this demo, I'm actually going to tell a story, and hopefully that will be a happy ending for the story. Okay? All right. Here I'm logged in as a tenant, right? I'm a new tenant. I'm trying to use the Azure Stack, and I'm happy I got access to it, and I went into my subscription. It turns out I already created a subscription, and I'm trying to go access the storage resources in that subscription, right? So for that, I'm going to try to do a template deployment because everyone is talking about ARM and everyone says it's cool. So I'm going to go give it a try, right? Within that, when you go into custom deployment, it gives you the ability to define your own ARM template. And of course, it gives you some sort of boilerplate. And here you can see that the GitHub repository that I was talking about, I'm just going there, copying a bunch of code, JSON code from that template and pasting into my custom template deployment, right? So it seems like the right thing to do. Yeah, sure enough, it has a parameter, and the parameter is the account name. Now, and that parameter I just need to provide it, whatever account name I want to, and I think I'm using my account 2 here. That is the account name that I picked for the purpose of this demo. And I'm going to have to take that resource and put it into one resource group, right? Resource group is typically you organize a collection of resources into a resource group that together serve the same business purpose, right? So yeah, you kick off the template deployment, the deployment started and it succeeded, which means my storage account got created in that resource group that I just selected, right? So I go see that, and sure enough, my account 2 is there, which is good. Then I take a look at what's happening, and I just want to make sure it has the right parameters that I specified in my ARM template. Yes, it has the LRS storage. It seems to be created under my subscription. Everything looks good. Then I click on access keys, right? The access keys are the same as in Azure. They're used for authenticating a user to have access to a storage account, the objects in the storage account. I have 2 keys, just like in Azure, key 1 and key 2. And I'm copying one of the keys because I just want to start using this in a moment, right? Now, what am I going to do with that key? It turns out I have a few blobs that I want to, few objects, few things that I want to upload into my account and access as blobs, right? So I have so I copy pasted that key here. AZ copy is an Azure CLI tool. For those of you who already know it or you don't know it, it is the same tool, same binary. I'm not changing anything. I'm just using a copy tool. I also have a virtual disk and a few JPEG image files that I want to upload, and my hope is that I will upload them as VHD, page blobs, and block blobs respectively. Oh, before I do that, let me actually go create a container, right? So I'll go create a container, and I give it the name that I had already picked in my script, as you guys had seen it, and remember, folks, this is really the same tenant UI as in Azure, right? This is the exact same thing. The same tenant user experience continues here on Azure Stack. So create the container that works just like in Azure. That's cool. Now, let us try to go upload the blobs into this container, which is as simple as really copy-pasting that into a command window and letting it go, right? So AZ copy works just as you would expect in Azure, just is uploading the blobs into a local storage account running in your local Azure Stack deployment. Once all the blobs are uploaded, let's refresh and see, yep, they are uploaded as page blob and block blob just as we had expected, which is all goodness. Now I'm going to run some applications on them, use the blobs, do something with them for some time. I'm happy, right? I'm a happy first user. I'm having fun. So I'll do that. So I did that for some time, a couple of hours. Again, this is sort of time accelerated video here. Finally, I said, I'm done with this account. I no longer need it. I'm going to just go ahead and delete it, right? So for deletion, again, it's the same as in Azure. You go there and hit the delete button and confirm it by providing that specific name, and poof, it goes away. So yeah, let it do that. Once we do that, the deleting the account is complete, and I make sure that it is really gone. I want to go to my subscription, right, and see. And of course, nothing shows up there. then that's the moment of truth. What? Did I delete that account and all the blobs and containers, all the data gone? No, 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 I actually wanted that data. Some guy, some application, someone comes in and says, oh my God, did you delete all my data? What happened to that, right? Well, in the case of Azure Stack, I pick up the phone and I call my administrator, who seemed to be a friendly guy. I'm going to call him and ask him what's happening there. Is there any way to retrieve the data, right? So now I changed roles. I'm acting as a service admin, as you can see up there, right? As a service admin, it turns out there's a possibility that I can help to make the story a happy ending, right? So I will go into my resource provider view, which is sort of the administrator view that I mentioned earlier. This is only admins have access to this. And I click on storage and see what's going on there. There are a bunch of accounts. So I click on this tenant resources and pull up the list of storage accounts. Actually, an interesting thing here you can see is storage accounts are used for a number of purposes when you deploy Azure Stack. Events and gallery items and health information, usage information, they all have discrete accounts, right? So now, in addition to that, of course, it also shows up the accounts that I have, my tenants have added or deleted, and it shows up the account. Sure enough, it is still there, and it shows up as deleted. Well, of course, yes, it is deleted. Now let's see if there is any way to retrieve the data, recover the data, right? Oh yeah, it turns out that there is a retention period for storage account, right? So within that retention period, all the data is kept around just in case emergencies like this happen. Now recovering the data seems to be going well, and there is no problem, which means there's also the other interesting thing that's going on here is when we restore it, we're really undeleting an ARM resource under the covers, right? So we need to go tell ARM as well, Azure Resource Manager, hey, there's a new resource that actually reappeared. And here, right, so look at this. So basically the account became active again, which means that's good, which means the storage account from an admin's perspective, the account undeletion is complete, and the account entry, the namespace also shows up back again. Now let's continue on with, 1 second, yeah, with the tenant view. So I pick up the phone and call my tenant back and tell him, hey, it looks like your things are back up. Can you please go check, right? So the tenant is going to my account too and trying to see the account is there, first of all. That's good news, right? It means that the namespace came back. And then he's going to look at the data in it, and that's really the critical piece here. And it looks like the data is there, at least the container is there, and then of course the data is there. So then, of course, there's a happy ending here. I love my service provider, right? With that happy thought, I'm gonna stop. I'm gonna hand over the baton to Scott, who's gonna go deep into the networking side of the house. Thank you.
Thank you, Balakarjan. Again, my name is Scott Napolitan, and I'm going to talk about networking. And I'm the program manager that's responsible for delivering networking in Azure Stack. And okay, so I'm a lot of content to get through. I'm going to try to avoid lapsing into auctioneer voice. But with that, let's just jump right in. So,
not me.
Azure networking, Azure Stack networking is really the best of both worlds. And so what we've done is we've taken a lot of technology directly from Azure, really forklifted the code directly from Azure and put it into Azure Stack. So battle-tested hyperscale components that we're using in Azure, like SLB and the virtual filtering platform down at the data plane, which is the switch extension for Hyper-V that enables a lot of the data path operations that we do, are brought directly from Azure. We've combined those with the new features and cloud capabilities that we're delivering in Server 2016. And so what we give you is we've got some features like really down at the data path, like switch embedded teaming and offloads and packet direct. So in some regards, we actually have some capabilities that are ahead of Azure. So we've taken really the best of both worlds and combined them together for Azure Stack. So how many folks have attended the Server 2016 SDN presentations? SDN in 60 minutes. See a few hands. So Azure Stack builds upon the 2016 SDN implementation. So if you're familiar with that, then you already have some familiarity with this. Really, the idea is that Azure Stack, you're going to get that stuff installed and configured for you, for the most part. So we'll talk about it, but really it's just for your edification to understand how it works underneath. At the data plane, we've got really the physical network. It's fast. It's as simple as we can make it. It's static. It doesn't change. So we really have got a lot of sort of mature protocols happening down at the data path layer. We're not sort of doing any magic, anything special. It's simple, it's fast, and that's just what we want it to be, because folks said, well, how can you do what my switches do that are dedicated just doing that? How can you do that on server operating systems, and they're so heavyweight? And it's like, well, we're actually distributing that computing power across a lot of hosts, and it is actually quite fast. On top of that, we're putting the layer of virtualization, or the overlays. So we really got, again, as Mallikarjun indicated, we've got customer-indicated desired network topology, a control plane, and I'll talk a little bit more about this, where we actually hand off that list of desired state to the network controller, and the network controller just sort of turns that into a set of instructions, hands it off to the data plane that just processes it. So let's go down a little bit deeper. This is, after all, dive deep into Azure Stack IaaS. So at the management plane, again, you've got ARM handling authentication, authorization, orchestration. It's really the front door. So everything will come through ARM. ARM, in turn, talks directly to the network resource provider. And the network resource provider, like all the resource providers in Azure Stack, are really the ones that are responsible for sort of taking that infrastructure that we have and really delivering on the promise of consistency with Azure. So we're abstracting that complexity infrastructure away and surfacing it as via an API that's consistent with Azure. I mean, there's one SDK, and that's the Azure SDK. There's no Azure Stack SDK. So our APIs have to be 100% consistent, or they just don't work. And the resource providers are the ones that really make sure that this happens. We surface every resource to ARM as an Azure resource, like a primitive building block, kind of like, think of them like Legos. And you just snap them together via templates, and you can really easilize very complex topologies with some very simple statements. Underneath the network resource provider, well, we can play a little bit of jazz and do what we want there. As Mallikarjun showed you the slide where we're taking all these hyperscale services that are delivered in Azure that run across hundreds, in some cases even thousands of servers, and we're sort of compacting those into a very small form factor. We use some tricks underneath the covers to pull that off, and the network resource provider is really the thing that abstracts that and allows us to have the southbound interfaces be distinct and unique from Azure. But under the covers, the network controller was actually written and designed with Azure in mind. So again, the APIs and interfaces are pretty much Azure inspired, I guess we could say. They're based on we use the same nouns and verbs that are consistent with Azure to make sure that we can deliver all those resources at the control plane. And the network controller really take that set of desired topology that the customers indicated, the tenants indicated, and turn that into a set of instructions that it can hand off to the data plane. And again, the data plane is really it's a set of hosts. The idea is high speed, it's fast. It does a lot of very simple operations in a distributed manner, and it's just fast, dumb, reliable, robust. A little bit deeper, I'm not going to talk about this one too much because I'm sure you've all seen at least a version of this or another. And again, you can go look at it offline. Marketing said, God, this is an eye chart. Please don't put this in there. It's really good to refer back to because I think it's very useful to know sort of what's happening. The takeaway from this is, the thing I want you to take is to understand the network controller there that does a bulk of the heavy lifting in the control plane at the infrastructure level. It's a componentized architecture. It's not a monolithic, it's not a single binary, it's a bunch of binaries, and it's a bunch of services that handle each of these network functions. And I'll talk a little bit more about each of these in a bit more detail. But again, we've got open protocols like OVSDB at the southbound interfaces there. And that's going to make us make it easier for third parties and things to integrate with us at the fabric layer as we go down the road after GA and things where we'll start to have a lot more partner integration. A host level, let's just talk about this just real briefly. We have, again, literally billions of flow actions to packets. We've tested this at pretty large scale. Of course, Azure, we've had it tested at hyperscale. And each host performs the operations that are associated with the VMs and the VM NICs and interfaces that are attached to it. And so you have that distributed processing power on each host. Things like ACLs, network security groups. We've also referred to network security groups as the distributed firewall. So literally each VM processes those rules and at each host. And so it's very, very fast, very robust. And we take advantage of, again, things at the platform like Packet Direct, SRIOV, and offloading. And so as we introduce more capable NICs, when we get into the distributed systems, multi-node systems, you'll be able to see the performance gains there. A little bit hard to measure, as Mallikarjan says. TP2 is not something we expect people to be able to start measuring performance with, but we have done in our labs, started to do some of this performance testing. And you'll be able to see that soon. Okay, so in the array of Azure services, network services that are available in TP2, we're delivering virtual networks, load balancers, and VPN gateways. Virtual networks and load balancers is something that if you played with TP1, how many people have played with TP1? All right. So if you played with TP1, you already got to have a taste of the network load balancer and virtual networks. VPN gateways are new. Site-to-site gateway capability is there now, and I'll talk about that a bit more. And these are the resources that we're providing in TP2. And again, we've got some new ones there in user-defined routes. And again, the gateway resources are there. Also in TP2, we've actually enabled those to be created via the portal. So those are part of the marketplace now. So in TP1, you could only realize those via templates. TP2, we're actually going to let you create those from the portal. So that'll make life a little bit easier. So virtual networks. I'm just going to go through this architecture very briefly. Again, virtual networks, if you're not, who's not familiar with virtual networks? Okay, good, nobody. That guy. So it's really just being, network overlays, virtual networks are really sort of, the idea is, the network is static, it doesn't change. However, you can indicate any network topology you want to, and it'll sit on top of the physical network and in isolation. So, tenant A and tenant B, they don't see each other, and they can realize any topology they want to, no matter how complex. And those networks sort of float free from the physical topology, so they can be moved around, stretched across premises, and interesting things can be done with those. One thing I did want to mention in here, because I don't talk about it anywhere else, is it's new in TP2. We also are bringing IDNS in. And what IDNS gives you the ability to do is we can do internal VNet resolution, so VM to VM name resolution is there by default. So you'll be able to ping VMs in the same VNet by name. In addition to that, we'll have forwarding capabilities, so you'll be able to resolve internet names and things like that without having to provide your own custom DNS, like we did in TP1. So again, that's something that'll make life a little bit easier, and as we go forth, we'll be providing additional DNS services in future releases. And this just goes back and relates the functionality that we're delivering with virtual networks to the components that I showed you earlier. So again, we've got the virtual network manager that's responsible for making sure all those policy mappings happen. And really, the NC host agent does all the heavy lifting at the data plane layer. And this just shows the interaction between those. Again, something that I'm not going to spend a lot of time talking about, but I welcome you to refer to these offline when you review the deck. Network security groups. So network security groups, again, there's something that's new and again, are enabled by VFP in 2016. And it's really a distributed access, so it allows you to define at the virtual network layer or down to the individual network interface layer a set of, think of them like firewall rules, right? And with this layering, we can actually create some very sophisticated sort of and very granular network control. And this is something that we find that, talking with the networking departments, because a lot of times, folks are trying to sort of convince the networking team, well, this is something that we should adopt. And, having this ability to lock things down very tightly is something that networking teams generally really, really like and agree with. So it plays a lot friendlier in things like DMZs. It allows tenants to sort of configure their own security. It's secure by default, and so things are generally locked down. Everything's locked down instead of everything being opened up by default. So tenants will actually open things up as they want to expose ports and services and protocols. User-defined routes is something that's new in TP2. So user-defined routes allow you to actually create some fairly sophisticated routing rules in the virtual networks. Really, they pave the way for things like virtual appliances and bringing that virtual appliance ecosystem from Azure, which is something we're looking to do. So you want to put things like your F5, your Barracuda virtual appliances in your networks. You can create some sophisticated user-defined routes to manage the traffic that flows through those, or which traffic does not. And those are exposed via a very simple set of rules that are fairly easy to program. And again, look just like everything else, exactly like they do in Azure. And of course, forced tunneling is a popular use for user-defined routes, as you can force traffic as opposed to going through the VIP, which traffic will do by default. And again, I'll talk about that in a bit. In fact, right now. So the software load balancer is something that's new. If you're familiar with WAP and if you're familiar with 2012 R2 and the VMM solution, this was something that you had to deploy gateways to get the VMs to talk out of the virtual networks. And so one of the things that software load balancing does, apart from the obvious thing, which is balance requests across multiple hosts on the back end via a VIP, which is something, of course, that SLB does. It also handles outbound NAT. So without having to do anything, you deploy VMs, and they'll have outbound NAT through SLB. And so they'll have that connectivity outside of the VNet without having to deploy additional gateway services. That actually can be locked down, but by default, it's opened up. And of course, in order to get whatever ports or ranges you want, you can go and open those up explicitly as well. And of course, you can do inbound NAT rules. So this is going into the component architecture again. I'm not going to cover this in much depth because it's more of a refer back to it for reference. But just to show, the SLB manager is the thing that actually handles tracking of the VIP to DIP mappings across the fabric. So at the policy level, the SLB host agent service is something that runs on each host and the SLB manager talks to. That actually handles NAT at the host level. And of course, the traffic is forwarded via BGP advertisements. So each VIP on your Azure Stack Fabric gets advertised via BGP to the TOR, to top of rack switch. And in doing so, it's advertised outside of the stack to external networks. So whether that's on the public internet or it's your corporate intranet, those routes are exposed back into the stack, so they have reachability from outside of the STAN as well as inside. So let's talk a little bit about cross-premises connectivity. This is something that's new. So site-to-site VPN is something we've introduced in TP2. I'm definitely not going to talk about this diagram. This is for you to refer to. This is how to connect a one-node POC to the public internet or to Azure. I actually had an MVP ping me about 2 days after we released TP2 and with a complete blog document about that he had actually done this already, which is really, really nice. so before any documentation was even released, he was able to connect an Azure Stack proc to Azure, which I thought was pretty cool. But the idea of the site-to-site VPN, where you can connect to Azure Stack to Azure, Azure Stack to another Azure Stack, or Azure Stack to an on-premise router acting as a gateway there. It's a secure site-to-site tunnel. It uses IKV2 or IKV1 protocols, are both supported. And it's really a secured tunnel between two premises, allow you to extend your network so layer 2 looks like it reaches across, and it's actually invisible. They look like they're right next to each other as opposed to going over the WAN. How are gateways implemented in Azure Stack? Again, this is something where our implementation underneath the covers is a bit different from Azure. We're able to take advantage of the multi-tenant gateway in Server 2016, which is one of those things that allows us to actually take the infrastructure that Azure uses to deliver that same service and actually shrink it down to a very small, much smaller scale. So we actually have a gateway pool and gateway instances that actually provide that function in Azure, and it's a multi-tenant service, and so tenants are able to take advantage of it as common infrastructure in the fabric. And what they do is, again, the process for the tenant perspective works exactly like it does in Azure. You create a virtual network, a subnet, and a gateway subnet. You create a virtual network gateway resource and put it in that gateway subnet, and then a local network gateway on the other end, whatever that might be, whether it's another virtual network gateway in Azure, or a physical device somewhere, or another Azure Stack gateway. And that actually talks through the gateway instances. So the gateway, it's just really a set of policy settings. The gateway instance in the Azure Stack Fabric infrastructure is the thing that does the actual business of routing. A compartment's created in that instance, and it advertises that to the Tor via BGP again, and so that secure tunnel can be made directly to that instance and then to the VM's virtual network. We do not have BGP support in TP2, but that's coming. So right now, you'll have to indicate those subnets that are available on the other side of that gateway by hand. So the scenarios in TP2, again, that I talked about, I've discussed these, I think. The one thing I do want to call out here is there's one under hybrid network scenarios that's about traffic manager. So technically, we do support, we'll act just like another traffic manager endpoint. We do not have, just to be clear, traffic manager resources in Azure Stack. Traffic manager, who's familiar with traffic manager? Can I just see a few hands? There's a few folks. So traffic manager is something in Azure that allows you to balance endpoints really via DNS across multiple regions or even outside of Azure. Right, so if you've got services that are geolocated, that are all behind, say, the same DNS name or maybe a DNS subdomain, Traffic Manager will help you create rules that will actually point you to one place or another, be it in Azure or US West or US East or Southeast or wherever it may be, including Azure Stack. So Azure Stack can play with Traffic Manager and public Azure in that way. For now, let's move on and talk about some of the compute services. So compute is really the resource that sort of brings everything together, and it's the one that most folks will interact with most regularly. It's the one they associate with IaaS most easily. We enable Azure Compute via the compute resource provider. And so, again, like every other resource provider, we're able to provide a simple set of resources that folks can easily deploy on top of a set of sophisticated infrastructure. We've got in-guest VM customization, and so you can add custom images, which I'll talk about in a little bit, and extensions that are also available in Azure. Allocate compute resources across tenants. We'll talk a little bit about how that works. The job of the administration is really between posting custom images and extensions, allocating resources to tenants, and really sort of managing capacity of the fabric. that's really the bulk of the compute administration. Let's talk a little bit about the infrastructure behind it. So CRP, a bit like some of the other pieces, it's a microservice architecture, so it's not a set of monolithic components. Each component provides a specific function and can be updated. It's individually and serviced. It's more resilient. It's more robust. And a lot of those pieces were taken directly, again, from Azure. So it's robust and it's scalable and it's proven technology, sort of field tested. The compute controller is something that's new in TP2, and it's something we've introduced that wasn't there in TP1. And what that's going to allow us to do is actually have a lot more control over placement. Once we get into scenarios that involve multiple clusters, you'll be able to do things like hardware partitioning that'll allow you to specify, particular instances can be deployed to a specific cluster. And when you're creating offers and plans and getting those resources to tenant subscriptions, so you create offers and plans that are for premium instances, for example, and you can have tenants that go specifically to certain clusters. That allows you to sort of provide preview functionality on specific hardware in specific areas, and it gives us that new level of sophistication that we'll be adding features to down the road. And one piece here that I want to leave you with is that Azure Stack does have a technology that doesn't exist in public Azure, which is failover clustering. All this infrastructure runs on top of failover clusters. So you have that availability, and it gives us a lot more flexibility in terms of servicing, patch and update, and things like that. Particularly for IaaS VMs who, if you've got a single instance IaaS VM, is anybody familiar with single instance IaaS VM in public Azure? The mechanisms there is it's generally, you want to provide more than one instance. Don't use a single instance, it's the guidance. And the reason for that is there's no capability to do failover clustering. Azure Stack will bring that. So you'll have a lot more sort of options around keeping those things up and running, particularly for IaaS. In Azure Stack. So we'll talk a little bit about the virtual machine pipeline. The way that Azure Stack goes about creating a VM instance is a little different from the way it's created in sort of classic Hyper-V. The way we put them together. Mallikarjun talked a bit about the interaction between SRP and CRP. The tenant goes and makes a request. ARM does, there's a template validation. We build a sort of a VM placeholder that represents the VM. We do the orange box there, select cluster and host. That's something that we hand off to the compute controller, and they figure out where the best place to put that instance is. We then talk to the storage, the SRP, via protocols between the CRP and SRP. To acquire that page blob for the VM. We then go talk to the network controller to create the network interface or interfaces. We register the usage meters and then go ahead and start the VM and start customize it via the extensions. So all these components work together. CRP, NRP, and SRP all have, since they're the core RPs, they've got APIs that talk to each other to make sure that this orchestration all happens perfectly. And there are no mistakes. And so if you actually ever sit and watch a VM sort of take shape in Hyper-V in the TP1 proof of concept, you'll see that it's actually built, you can actually get a sense of how we put these things together. Because they're all sort of atomic pieces, again, like bricks that come together to create that VM from these different resource providers. And it's all orchestrated. Deploying VM extensions. So in-guest extensions allow us to do a lot of customization of a VM. Again, just like Azure, there are in-guest agents. For Windows, there's a Windows guest agent, a Linux guest agent. There will be a supported Windows and Linux guest agent in Azure Stack. The Linux guest agent, for example, is provided in Linux VMs. And the Windows guest agent will come with the default Windows VM that's there. So if you deploy the portal, you can see the Windows VM is there in the marketplace by default. and that comes with the agent installed already. If you're going to be building your own custom images, you want to make sure to grab that latest guest agent off of GitHub and make sure that you're putting that guest agent and prepping that VM and uploading your VM instance that way. So the nice thing about Azure Stack is it's Azure in your data center, and I know we've heard this and we've said this a lot over and over, and not just this presentation, but others. But the nice thing about it is it's your Azure Stack. So it's your Azure. And a big piece of that is actually curating content for Azure Stack, uploading your own custom images into the marketplace. So you're really exposing what you want to your tenants as a cloud service admin. Putting Contoso's golden image is the canonical example here. The idea is that you can put your own images up. Of course, we will warn you that if your custom VM images have dependencies on your own corporate infrastructure, for example, you really need to be careful there that if you want to make sure that those images remain portable to Azure, that you have a way to sanitize those so that they work just the way they do in Azure and don't depend on any infrastructure. But of course, if you mean only use those internally and you don't depend on you don't expect them to be portable, you can put your own images and expose those to the tenants that you want. And this functionality is the core underpinning of marketplace syndication, which will allow you to basically pick and choose the items that are in the Azure's marketplace as a cloud admin and pull those down into your own Azure Stack so you can choose the ones that you want to offer to your tenants as well as your own custom images. So compute features in TP2. Again, we've got generalize and capture. So you'll be able to actually, via the portal even perform generalize and capture VMs. So again, if you're intending to make images portable between Azure Stack and Azure, this is a really useful capability because you can pull those images down, package them up, and then just push them right into Azure and use them there as well. Stop deallocates, a new feature that allow you to sort of stop the VM. If folks are familiar with stopping a VM from the Azure portal in Azure, what actually happens is that does a stop deallocate, which tears the VM down, so you're not charged for it. And so this is something that a lot of Azure customers ask for. Of course, we're not charging for VMs or anything for that matter in TP2, but this is functionality that's there for you to evaluate. Template consistency, so we've got custom data fields in the OS profiles and secrets as well, and I think that was demoed in another session. The self-service diagnostics. One thing that's not here is there's that was, again, really cool demo. Is the ability for the cloud admin to actually go and reset a user password for their VM. And this is a feature that, if you've ever had a tenant that locked themselves out of their VM, they couldn't remember what their own password is. Typically, it was a brick. But there's a feature, an administrative feature for compute that will actually allow you to the users, not just the admins, the users actually go reset their own passwords. So there's no longer a call to the help desk or a ticket for that. They can actually just help themselves reset their own passwords if they've forgotten them. And of course, the extensions and the compute controller is a new piece. We've also added quota enforcement and administrative APIs for managing those. And of course, the VM image management, you can add your own custom images. So bringing it together, Azure Stack is a collection of foundational services. It's really, you have to have IaaS before you can offer PaaS. And so we're starting there. The services that PaaS builds on are all the services that we need in IaaS. And so we'll start delivering more and more PaaS services. We really don't want you to think of GA, even if it's next summer, as sort of the endpoint. It's really the starting point. We're going to continue to add more and more PaaS services and more features because we know, customers are probably going to try and test the waters with IaaS, and then they're going to want to move right on to PaaS and start deploying those services. Again, IaaS resources are provision managed. It's the same, one SDK, the Azure SDK. And so if you've used that, you're already familiar with the Azure Stack SDK because there's only one. The portal is a consistent experience. There's really no learning curve if you're switching between the two. It looks, tastes, feels just like Azure. And of course, the cloud service, we're building on the software defined data center capabilities that are in the platform. So it's an all-new stack from the ground up. It's not a V2 of the current in-market product. It's really a very new thing. It's Azure in your data center. This is something that we don't have on the slide, and I don't know if it's mentioned in another session or not, but I've gotten this question frequently this week down at the Azure Stack booth, and it's one thing that a lot of folks ask me about is, sort of how do you bring servers in and sort of use this to sort of, manage your data center? And that's not really what Azure Stack is. It's not a generic data center management tool. Everything is very fixed and works. The pieces are designed to work together. So the management tools, and I highly encourage everyone to attend Charlie Satterfield and Thomas Reidinger's session, How to Be an Admin, Azure Stack Admin Rockstar, at 4 p.m., 31:15. Attend that session because it's going to be absolutely great. And he's going to go over health and monitoring, a lot of lifecycle management pieces. Those pieces are all built to specifically be Azure Stack monitors. It's an Azure Stack solution. So it's a packaged solution. It's not a generic data center management tool. So we're trying to get folks to think about it a little differently. It's Azure in your data center. Have mercy. I gambled and lost. But Mallikarjan's went very well, so don't punish him for my failed demo. And one other thing, there's some free IT Pro resources that we've been told, we encourage you to go out and take a look at to ramp up. Those are very good. I guess with that, I'll open the floor for questions.
Feel free to stop. I don't have a mic anymore anyway.
No?
Ask them to come by the booth.
And by all means, if you haven't stopped by the Azure Stack booth in the expo hall already, please do. Everything seems to be working there. Can we ask you to move to the mic for the question?
So the question is, the former integration services in Hyper-V in the guest VM is gone, and now there's another extension running in the VM. Is this right?
So the guest agent, the guest agent in there's a Windows guest agent and a Linux guest agent. Those now those do the work of
so that formerly run on Hyper-V stack.
That's right. Wow.
Quick question. So will the site-to-site VPN have the same limitations that Azure has as far as bandwidth capabilities at 200 megabits per second, or has that limitation been lifted?
So the question is, will the site-to-site gateways in Azure Stack have the same limitations in terms of bandwidth? So the Azure Stack site-to-site gateways, if you deploy via template, whether it's Azure or Azure Stack, you actually aren't presented with a choice for SKU. However, via templates, you can specify a default standard or extra large. The throughput sizes, the speeds are the same. However, there is an important difference between Azure's gateway instances and Azure Stack's instances. In Azure, what you're defining there is the throughput for the entire gateway instance, not the connection. And so in Azure, you've sort of got to figure out, based on the connections that you connect to that gateway, sort of split your budget for that bandwidth amongst all your connections. In Azure Stack, that number is for each connection. It's the same number. It just represents the connection bandwidth rather than the entire gateway bandwidth. Now, in terms of the number of gateways that you can deploy, that a given tenant or subscription can deploy, and the number of connection objects they can create, those are configurable by the admin via quotas.